Okay, hello, welcome back to another one of my video log recording sessions on the topic of genetic algorithms. The date is 2025, March 23rd, and today in this session, I'll try to cover two Jupyter notebooks related. One titled Genetic Algorithm Grid Search 340 Items Revised, and the other one named Genetic Algorithm Grid Search 350 Items Revised. So revised as in it is the revised version of, these are the revised versions of the files that I did some time ago, but with a new metric, like I've said time and time again, the new metric being the average of top 10% entities that take into account how many entities there are at each summed utility value. So in this notebook, in this particular notebook right now, instead of 20 or 30 items, I have 40 items, because I wanted to see if the peak and the plateau and the dip, which is the difference between these two levels, still exist while the new metric is still, is applied. So let me just check. Well, I haven't done the same for, I haven't done the revised version for the Grid Search 330 items, because well, I kind of know the answer, actually, which is kind of like cheating. But as far as we know right now, that when given only 20 items, the dip is quite minimal. It is quite, it's hard to detect. It still exists, but it's hard to detect, and it is quite negligible. So with 30 items, the dip is now more pronounced, and the point of doing it with 40 items and 50 items is to see if the dip gets any bigger. And long story short, it does. But the point of these two notebooks was to see if, again, the new metric, the average of top 10% or top 20 or top 50% still show that same behavior. And it, again, TLDR, they do. These two conditions, 40 items and 50 items, they do. But and I'm only here to show that, aren't I? So we have I have 40 items here and 40 values for the utility, and 40 constraint values, or 40 values for physical weight. And all things are, quite the same, everything, except now, again, I have the compute average summed utility, average of summed utility values, the function for that. And instead of writing all the procreate section, I have the function to do that, and I'm sticking to varying highs, which is dividing the population size by 1, 3, 5, 7, 9, 11, and all the other odd numbers, depending on where the entities come in order, in descending order, in terms of some utility values, when calculating the weights at which they'll be picked as parents And here are the hyperparameters. Max constraint being 6,500 for 40 items. Population size is 500 in this case. In these two notebooks, I didn't increase the population size. I didn't have the ultimate stage where I increase the population size step by step to see how they change, how the values change. I didn't do that here. I thought that was more than redundant, so not required here. So population size is fixed at 500, and the generations, the number of total generations is also 500. No relation there, just 500 I thought would be enough, and I have seen that it is enough in this case, so no point in going any further. No point in doing it 3,000 or 30,000. So same procedure: create the void genes, create the genesis 0 from the void genes by using deep copy, and yeah, start the evolution. In this notebook, I also got the average of top 50%, just for the sake of it. Just to see, but it doesn't prove to be that helpful. But I did it anyway because I can. I felt like it. Who's counting? I am, so it doesn't matter. And this whole process took 77 seconds on my MacBook. So not going to run this right now because it's going to take about 80 times 3, 240 to 320 seconds. So I don't want to do that. Maybe I can in the future. Maybe in 5 minutes when I've run all of this, and then I feel like I should run it again, and I can rant in between in those 10 minutes because I have 2 notebooks, and that's 5 minutes times 2, so that's 4 to 5 minutes times 2, so that's I think that's fair. And the maximum summed utility value ever was, in this case, 1080. Good number. And here are the plots for the heads. See how they all oscillate up and down, and they sometimes touch the 1080, sometimes not, and then they fall back down. These values here are more volatile because, well, they're just values of one single entity per generation, so they're not averaged out. But they're still, when they're high, they reach the maximum ever. When they're low, they're nowhere close to that, but you get the point. And here are the plots for the tails. So somewhere around 200, going as close to 300, but yeah, quite low compared to what it could be. The max ever is the gold dotted line here, like as shown here. And here are the plots for the top 10%. The purple one is for the max value for the average of top 10%, and that is still not as close to the gold line, but that's expected because right now we're looking at the averages of top 10%, which in many cases will be average of 70 entities. So that's kind of expected. But what I aimed to see, or what I wanted to check, was if the dip exists, and the dips exist. So this is about 950, the purple line, and the plateau is around 800, so that's about 900 minus 800 is 100, well 950 actually, so it's about 150. So 150 divided by 900 is 1/6, which is around 16.6%. So 15 to 17% difference when it comes to the dip size, the size of the dip. And this is the result list for the top 50%. As you can see, there are no, the dip is quite minuscule compared to this. So when we zoom in, this again for the top 10%, this is expected, as I've seen that they always peak before 60 or around 50. Sometimes when it's quite early, it's around 30 or 40. And these are the plots for until generation 150. Same plot, plateauing at around 800 until generation 200, same. And this is one of the distributions, and as you can see, well, there isn't really much you can see here. It's kind of normal distribution, but keep in mind that this is at the end of the 500th generation for the last run, so this doesn't entail the entire picture. This is just a snapshot of the last run. Same thing, but in a bar chart format. So we've just seen that there's a 16% decrease when it comes to in terms of the dip size when dealing with 40 items under these given conditions. And then moving on to 50 items, I create the 50 items, I assign the 50 values for each utility values and the constraint values, and everything is the same procreate function. Do the same, we move on to the assessment, we see the same thing, but one interesting thing that I think I just forgot to mention is that when we look at the results, or now I should mention it right now, when dealing with 40 items, the values for the heads oscillate, and then they sometimes touch the maximum ever value. So there's still a chance that that some entities regain their past glorious form. But when it comes to 50 items, that doesn't happen anymore. They peak, and then they plateau. Even the results for the heads. So this is very intriguing. I wonder why. And for this, I think I will have to go through that tedious process of recording all the entities per generation and actually dissecting how things change. Of course, to do that, I'll need to actually name all the entities within each generation and keep a log of what got changed and which genes got mutated, and which entities got struck out, and etc., and which entities emerged as the new head, or which entity kind of fell to be the tail. Not fell, but were just kind of unlucky. So again, the heads are not returning to their maximum ever value. For the tails, expected. Yeah, so nothing that unusual here. I think for the tails too, they don't reach the maximum ever value for the tails either. Yeah, that's one interesting thing that I did not see last time when I actually worked on this notebook. Here are the plots for the top 10%. Again, we have the plateau at 1000, and the purple line, which is the maximum value for the average for the top 10%, is at around slightly lower than 1300. And we have 1000. So let's do the quick math. Minus 1000, which is obvious, and then divide that by 23%. So we have a 23% decrease in terms of, the dip size. So approximately around 20. And they never gain back. And I bet you that when the same happens for the dip still exists for the top 50% too. But I bet you this happens when, and this is the first time I'm actually assuming this, but I bet you this happens when we lose those values, the top values, when we talk about heads. So we lose that before 100, before generation 100. And when we have a look at that, let's look at the plots for until generation 200. Yeah, that's when it happens. Before 100, this is when we lose all the heads, and then we taper off, only to suffer that 20% also decrease in dip size. And here's the distribution. Again, just one slice. Just one final state of the last iteration of the evolution. Yeah, 10 times. I evolved for 10 times. So it seems that the more items there are, the more genes that we're talking about, the more pronounced the dips tend to get, which is odd, but maybe it's obvious. I don't know. I still have to do that work, that tedious work. But for now, I can just assume that it is because of that reason, the fact that there are more genes to lose. And yeah, the next videos will be about how to control this dip, which I still haven't actually found a good answer. I have some 50-50 kind of good-ish solutions to this, but I don't have a really good way of doing this in a very organic way, other than preserving just bluntly and outright preserving the top entities, which I don't really want to do. Because if you think about it, I don't want, well, I do want some top entities to go on to the next generation, because just by the virtue, or just because they had high summed utility values. But I'd like to believe in how the pool, how the society works, and how we can keep generating good enough entities, or more than good enough, excellent entities over time, continuously, until the end of time, until the end of max number of generations. And because only by ensuring that can you increase the number of genes as the evolution continues, and hope for a upward slope. I don't like this plateau. This is a very, very sad, in terms of sentiments, in terms of emotions. I believe that this is a very sad state. It's like somewhere around generation 200, some entities will look back and say, oh, we had some very good entities that were really, really high up at 1480, the maximum ever, but we don't know how we can actually do that anymore. The information has been lost. Of course, the another way, a good way of doing that is to actually preserve the information, like how we do, how actual humans do, as in by word of mouth, by recording it, writing, and passing it down, generation after generation, which I think is a good way. But I'd like to find something more organic. That's what I'm hesitating about. That's what what this fuss is all about. And the reason I applied the new metric is to make sure that I wasn't actually measuring the wrong things before I moved on to trying to find a solution for controlling the size of the dip, or eliminating the dip. So now it seems that I wasn't actually doing it entirely wrong. I was on the right path, but there's still a lot of work to be done. Okay, I think that's about it. 22 minutes. So thanks for listening. Goodbye.